All right, we're back in action here. Here we go. Again, tell me if Tell me if that turns off. If that happens, and we'll run around in circles. Now, if we want to go from individual atoms or individual molecules into moles, what do we need to do? We need to divide by the 6.022 times 10 to the 23. Know how to use this E in your calculator. That will help you, that will save you time, that will save you points. If you use times 10 raised to something, you're running a risk. I'm telling you now, you're running a risk because sometimes your order of operations in your calculator messes up and you get a different answer. If you're going from moles into individual atoms, you're multiplying by 6.022 times 10 to the 23rd. Okay? Because a mole just is 6.022 times 10 to the 23rd. So if you have a mole of something, you're just multiplying by that number to get the individual numbers of things. Should make sense. Kind of, right? Okay. Now I always get this part mixed around because in my head I just think about the conversion factors. And so I have to think, okay, if I'm going from moles to grams, I'm going to put the grams on top, so it's going to be multiplied by the molar mass. Over here we go from mass to grams, mass to moles, we're going to divide by the molar mass. MM means molar mass. Okay?
What's molar mass?
Molar mass. It's all of the numbers on the periodic table mean grams of an element per mole of the element. It's a number on it.
Yeah.
So for instance, for carbon it's 12.011. Okay, so that's the chart. That's the mole chart. So I can give you any problem. I can say, for instance, I can say, convert individual atoms of carbon into grams of carbon. And you can do that by going from here to here to here. Right? I can say, go from moles to individual molecules. And you can do that by dividing by this, by multiplying by this number. Right? I can say go from moles to grams, or grams to moles, or grams to individual atoms or molecules. Those are all the ways I can ask you questions about conversions.
What's the difference between atoms and molecules?
What's the difference between atoms and molecules?
Yeah.
Well, in terms of this chart, nothing. So, for instance, if I have moles of CO2, CO2 is a molecule, right?
Right. So
if I have a mole of CO2, it's going to turn into individual molecules of CO2, right?
Right.
So it'll be a molecule there. But let's say I have a mole of carbon atoms. And then I divide by this, I multiply by this number, and I get individual carbon atoms.
Oh, so if it's more than one atom, it'll be called a molecule. But if
Exactly.
it's like one, only it's an atom.
Exactly. So it's a difference in those words right there. If there are a bunch of atoms clumped together, we call it a molecule. If it's just an individual atom, then it's just one atom. Okay? All right. With me so far? Okay. So I can ask you lots of questions about this. I'm going to say one right now, and you guys are going to be able to go through it like lightning. It's one of the hardest kinds of questions you can ask for these. I'm going to say convert. I'm just making this up right now. 2.98 times 10 to the 26th molecules of CO2. I'm going to stick with CO2. Of CO2 into mass. Or grams. Either one. Okay? Now, I'm going to go through this really quickly. You should be able to think in your mind what you do first, what you do second, what you do third. Right? The first thing I'm going to do is I'm going to say, okay, they're giving me this in the problem. So I'm going to write that out. Just automatically. I'm going to write it out. I've got this many molecules of CO2. Okay? So I start over here. That's how many molecules I have. I want to get over here to mass, grams. So I'm going to go this direction. So first thing I'm going to do is I'm going to divide by 6.022 times 10 to the 23rd. So 6.022 times 10 to the 23rd molecules of CO2. Okay, that's going to go on the bottom to cross this off. And it's going to be 1 mole of CO2. And you can say CO2 molecules if you like, but we know what I mean right there. 1 mole of CO2. Well, we're not done yet because we're only to moles. Now we're into this unit. Now we're going to go from moles into mass. So we're going to go this direction. We're going to multiply by the molar mass. So 1 mole of CO2 goes down the bottom. And this is going to be 12.011 plus 2 times 15.999 on the top. And these are going to be grams. Okay? So if you do that, and I have not done this yet because I just made it up, but I'm going to do it right now. 2.988. Let's say second E, my calculator, 26 divided by 6.022 second E, 23. Enter. Okay, and I get some numbers that's 496.18. Then I'm going to multiply by, and I'm going to say open parentheses, 12.011 plus another open parentheses, 2 times 15.999, close parentheses, close parentheses. Now I did that so I could separate this 2 times that, right there. I'm going to press enter, and I get as my answer this long number. This long number is 21836. I'm going to report this to 3 decimals. 415. And this is going to be in terms of grams.
Got a different answer.
You got a different answer?
Yeah.
Close price is 21777.
So 12.011, that part right there, that's with 21836.
Yeah.
So
I got
it's to like
21,000.
Did I put it in wrong? I
777.
think I put.
Yeah, in my head.
You did it in your head? Oh, wait, easy now. Oh, I know what I did wrong. I found my error. In my calculator, I put 2. I was so excited. I put 2.988. I didn't put 2.98. So I went too far. I said 2.988 instead of 2.98. That's my mistake. So if I do that right now, I'm going to do it really quick. E26 divided by, oopsies, divided by,
So the unit would be grams?
so the unit is grams, yes.
Okay.
Divided by 6.022, E23.
And it matters on like the order, right?
I can't do it like that. I just have to do it regularly.
You have to do it regularly?
I can't do the little brackets and stuff.
Can't do the bracket. What's wrong with the brackets? No love for the brackets?
No love for it, because I
Come on.
get confused which to cross off.
So it's 2, 1, so
No love for it.
Sorry, it's too long. Plus 2 times 0.999 is, oh, I got something different. It's 21777.951.
That's right now in my head.
In your head, wow, Curtis. You have a big head. I mean, no. 177.95, and I'm going to round it to 1. There we go. And this is in grams. Okay? This is a much better marker. Alrighty. Sound good?
Yes.
Okay, that's an example of one of the hardest kinds of questions I can ask you for mole conversions. So if you can do that, you can do just about any kind of mole conversion. Now, we're going to add a layer of complexity to this. And I'm going to ask you a hard molarity problem based off of this little chart right here. So molarity is related to this chart. It's related to this chart because, check this out, we got the moles right there. The moles are in the middle. Molarity, as Luke Kornblatt once said, is just moles over liters. Right? So moles are right here. You can put the moles right into this little equation. And you can get molarity. So if I give you moles and I give you liters, you can just divide moles by liters to get you molarity. Molarity is what scientists use as our concentration measurement. So if something's really concentrated, it's got a high molarity. It's got lots of moles of something per liter of something. And that should make sense to you. If you put more stuff into a confined space, it's going to be more concentrated.
Like the lemonade.
Like lemonade, exactly. Yes. Okay? So, let's see. What do we do now? Let's give you a problem with molarity then. Except now, I'm going to give you a harder problem than I normally do. This problem, I'm going to start off with grams. I'm going to say, given a certain amount of these grams and a certain amount of liters, find out the molarity. You can do that. So here's an example. Find the molarity, big M, of 2.5 grams of, let's say, carbon. In this many milliliters. In this case, I'm adding even another layer of challenge onto this by making this milliliters, because when you see the milliliters, you've got to change that directly into liters.
3 to the left.
3 to the left, right. So when you see that, you should just have this reaction, this knee-jerk reaction. You know what a knee-jerk reaction is?
Yeah.
Okay, it's when the doctors hit you on the, like
Oh,
that.
yeah.
So as soon as you see this, you should be thinking, ah! I gotta change that, oh, over there. Okay, so that's how many liters we have. We have 0.259 liters. Alright, so find the molarity of 2.5 grams of carbon in this many liters. So we start off over here in grams, and we're going to go and find moles and put the moles right there. Okay, so let's do this. 2.5 grams of carbon. How do we find that? Well, we divide by the molar mass, right? Yeah. Divide by the molar mass. That's the arrow going this way.
Equal 1 mole.
Yeah, very good. 1 mole of carbon. So this is going to give you, let me do this, 2.5 divided by 2.011. It's going to give you 0.20, I'm just going to set it at 2.08 moles of carbon. That's how many moles of carbon we've got. Alright, so we're halfway there to find molarity. Since molarity is this, I will give you this equation on the test. I'll give you molarity equals moles over liters. So you'll have that. You'll also have mole equals, yes I know. You'll also have molo equals midlin. And you'll also have 6.022 times 10 to the 23rd is 1 mole. So you don't need to remember any of those things. They'll be there. Yeah.
You divide 2.208 divided by 0.25.
Exactly. So to find molarity, we're going to divide these moles. We're going to plug this over here, and we're going to plug this over there. Okay, when we do that, right there, we're going to get 0.208 divided by 0.259.
No, 0.803.
What'd you get?
0.803.
Maybe you got it though.
0.803, you're right. 803.
04.
Come on.
Hey,
If you use these numbers, that's what you get.
I got 0.803639.
Come on, you're wrong.
You have to round up.
I got
Come on.
There's a 5, but it's
6.
5 or higher, you round up.
No.
No? What?
That's what I learned. When the fourth number is 5 or higher.
The fourth number is 0.
The fourth number is 6.
The fourth number is 0.
2 point.
The number after that.
Come on. 2.8 divided by 0.259 is 0.80308. Get out of here.
2.26, it says 0.5.